G'day! It's Chris the Guitar Home Tech from Sydney, Australia. Welcome to part 2 of the brown face restoration of the Pro amp. You remember from part 1 we discovered it was raped, pillaged and plundered by some asshole of a tech in Switzerland of all places, the home of quality. The reason I'm a bit excited is because this has come back from my transformer winding person, and this has just arrived from my Australian supplier of parts, Evatco in Queensland. And Michelle, who operates Evatco, is always meticulous in packing parts, expensive as gold, but they're the Sozo blue caps. It's about as close as we're going to get to the original blue molded caps that were pillaged out of this amplifier. Pretty good match. I wanted to restore this visually as well as electrically, and some 30 microfarad F&Ts. So I'm going to prove a point here. Do you know what a mega is? A mega is used for testing mega ohms, generally for things like insulation. But we're going to use it to see if these vintage, and this one would be at least 60 years old, leaks under high voltage. And I'm thinking it's not. So why were they all replaced? My best guess is theft or total incompetence. So we're going to prove it. Bit of a dangerous test instrument. As you can see, it goes up to 1,000 volts. Now this one's rated at 600 probably, is it? I can't see it, but I think it's 600. And this is what our display is going to look like if it has a bad leak. Test showing 0 ohms. But not all leaks are dead shorts. We'll test this 3.3 meg resistor, and we're going to assume that this is the leakage across a capacitor in our example. Bang, 3.2 meg ohm. Fast and quite accurate. Now I've got to say in probably 10 years I've replaced 2 of these because of leakage. I have come up with my own little leakage tool, which you may have seen in other videos, but this is going to really challenge it way more. So this is 500 DC across 600 volt cap. If it's got leakage, we're going to see it here. Well, let's even take it down to 250 volts because they're not always running at rated voltage over limit. So 250 is not a challenge for it. Let's go to 500. This is just under its rated limit for a 60-year-old capacitor. Let's see what Mr. Switzerland has to say about this. Right, there's 500 volts on there, not a problem. What's our highest B plus going to be in a typical Fender amp? I doubt if it'll see 500 volts. Let's go up 1,000 volts. This may fail because we're now talking about something which is not quite double its rated voltage of a 60-year-old capacitor. Let's have a look. There you go, Mr. Switzerland. You're a thieving bastard. Proof undeniable. These things never fail. 600 volt cap with 1,000 volts across those 2 terminals. No sign of leakage. Right, here's a Sozo at rated voltage. And this is rated at 500. So let's smack on its rating. Bang. Okay, I think these are going to be great and they're going to look the part. I think we can all forever be cursing the thief tech. Either sold them for a profit to people like me who want to restore an amp to original, or he's kept them for one of his own projects. I'm going to restore this as much as possible to 6G5, but can you see what this is missing? Not from the 6G5, not from the 6G5A. Give you a clue. Look at these 2 power tube sockets. Can you see something missing? That's right. There's no grid stopper resistor going to the grid. So I'm going to add it. I know it wasn't in the original circuit, but I think it's a good add which Fender have done consistently since then. Why is a grid stopper used? A grid stopper is used to prevent oscillations, minimise the effect of interference. It won't change the tone unless we go for a really large value. I'm just going to stick to the stock standard Fender 1.5K to go across there and across there. So I'll just need to reroute the grid connection. Seeing I'm here, I might as well start at this end. What are our last two coupling caps? Our last two coupling caps from the phase inverter to the power tubes, 0.05, 0.05, or yeah, probably 0.047. There we go. That's a 0.047. That's a 0.047. Let's get this looking right. Something is missing. Something is missing. Empty. Not permissible. Off we go. Make a coffee. Be right back. I need to apologise to my friends in Switzerland. Oh, how did that get there? A Swiss chocolate delivered by my Swiss friend. So, thank you, Mr. Lind. I mean, we have thieving arseholes here. I've seen this sort of thing before in Australia. I'm sure you've all seen it all around the world. I've seen some horrid work coming out of Sydney. Probably same all around the world. You know, there's not that many of these carbon film resistors. There's 1, 2, 3, 4 that I can see. All right, I'm going to replace these. If I've got carbon comps, I'll do that. That's these dark brown ones. If I haven't, I'll use my brown Vichy metal films, which I prefer, but the project is get it as original as we can, so let's see what I got. In a bit of luck, I found two 220K resistors as a carbon comp, which is what would have been originally used in here. As we would expect, carbon comp resistors nearly always drift up in value. This one's 225.5, this one's 225.6. So close. They're meant to be 5%, as you can see here. So why would Fender have specified them being closer than a typical 10%? Well, here's why. This is our bias circuit here. So the bias comes up here and then is split evenly between those 220Ks to the grids. I don't really care what value is here. It could be 150, could be 300, don't care, as long as they're the same. You've seen me using my dividers before. Because I like to get the legs really straight and well bent, the quality of work which Friedman or Matchless would do. I use the dividers to get my width, and then I also use them to bend the legs over. Then the other thing we want to take note of is where the tolerance bands are on all of the nearby resistors. Fender is excellent in maintaining their orientation consistently. So as we can see, the tolerance bands are facing that way. Straighten you up a bit. You're going to go there, and you're going to go there. But first, just want to give them a little bit of tinning. We'll be tinning this. Get my tolerance band pointing towards the rear of the amp. Voila. That's that. Now this is coming off the phase inverter, off the 82 kilo ohm plate resistor. And we don't like to have too much solder in these eyelets because we don't know what's happening underneath. But we know there's a lot of solder there, it just keeps on coming. Okay, that's got the most of it out. And this is off the 100K leg. Get the legs bent for our .047 blue Sozo caps. See that there is a black line on these. Now that doesn't mean negative. It's not a polarized thing like an electrolytic. It means the end of the foil. You'll see the Sozo caps have also, so that fella can go there. Beautiful. And this one can go there. Now, let me just straighten those legs up a bit. Make it look nice and pretty. Make it look like someone who cared about the customer's amp worked here. I am really happy with that. That is starting to look so much more right already. Let's just clean this flux off. Oh, I can't believe it. These wires are just rubbing on the unprotected edge of that hole. Good God. Beautiful. Already that's looking so much better. The rest of this is going to be all of the same stuff, so I'm not going to bore you with all of that. Now you might be asking, and quite rightly, how did I get these .047 blue molded caps? Did I steal them too? No, I didn't steal them. You'll see it is also the death cap. So when I take these out, I say to past customers, here is your little baggie of leftover parts. If you're not keeping this collection of repaired parts, would you mind if I had them and salvage bits that I can use? I'd say over half the time, owners would say, yeah, go for it, I'm not going to use them. And here is a .047. And here is a .047. And I'm going to see if I've got another one of these. If I have, I want to use the Fender Originals in that first stage of coupling cap, because my signal goes through that. Our very first stage in the normal channel and very first stage in the tremolo channel goes through a coupling cap. I'm going to replace this one with an original Fender one from my little stash. Anything to regain the original sound signature. Not sure if you can make this out, but it looks like capacitor guts to me. So I think before I put in my new old capacitor, let's just see if we can get rid of this capacitor guts. All right, hopefully I've got enough lead length. Oh, that's still correct. Oh, just get the flux out of here, mate. Yeah. Good. We want to be at least as good as what came out of the Fender factory, if not better. Next one. So I think I've got another .047 of the blue molded. I want to put it there, and that one will be one of the new Sozos. I'm very happy with the way this is going now. It's been a huge job. There's some things which I'm just going to gift the customer. I'm not going to charge them for. These cathode bypass caps, the ones that were there were fine. They just looked ridiculous. Pull them out. And instead of using the double 25 mic ones, which are just too big and very expensive, I've just done these, much more tasteful. I have managed to find a couple of the original .047 blue molders, which I've put in the first stage of both the normal channel and the vibrato channel. All of the other horrid orange ones have gone and replaced with the Sozos. What else? This is an interesting part of the circuit. So, how can you tell if you've got a 6G5 Fender Pro or a 6G5A, slightly later revision Fender Pro. Both brown face, both look identical from the outside. So one way I use to find which revision I've got is just look at the resistor values. There's quite often a change there. And the easiest ones to find are the power supply resistors, the dropping resistors. So have a look there, and indeed there is a difference between the 6G5 and the 6G5A. However, there's even a better way. In this particular instance, if we look at the tube layout chart, we will see there is 1, 2, 3, 4, 5 preamp tubes in the 6G5. In the 6G5A, 1, 2, 3, 4, 5, 6 preamp tubes. Much easier way of figuring out what we got. And we have got 1, 2, 3, 4, 5. So we definitely have a 6G5. But Fender was just making revisions like crazy. So as we will see, I think this is a bit of a transition amp because there is a difference, fairly significant difference, which I've had to do a little bit of a dance around, in the harmonic tremolo. We'll have a look at that. I think this is a transition eyelet board, because if this was the 6G5 board, there would be another eyelet just there. But there wasn't. So I copied whatever was done before, and the only way I can see this being a 6G5, part of the harmonic tremolo, was to have this one suspended up there. Yeah, that's what was there before. And because it's carbon comps, I'm thinking that Fender did the same hillbilly wire-up job. If anyone knows better, please let me know, because this particular part of the tremolo, as it should be another eyelet board there with a connection going to this 470. If it was a 6G5A, that was 220. Hidden another little resistor underneath this blue cap here, so to make my hillbilly modification to match the schematic of the 6G5. These are replaced. I found 200K carbon comps, put those in there. Ended up using a metal film, but yeah, that brown Vichy, which I quite like there. That one there, the original one of that had drifted way out. That's supposed to be 470K, and it was like 560. So I replaced that. That's in the oscillator circuit and the harmonic tremolo circuit, so it was a fairly critical value. That in there, that's a good Sprague one. I mentioned the role of the grid stopper, which was missing from this Brown series. I'm going to install a discrete little 1.5K under there. I'm going to replace that, which was clearly overheated there. I'm going to use these large brown Vichy. Once again, they look pretty close to the old carbon composition ones. And my mains wiring. And then when I replace that transformer, and hopefully all my work is trouble-free. I think I've done so much work on this, it'd be almost unbelievable if I got it all right the first time. Of course, nothing ever goes quite to plan. So this is the signal coming in after the coupling capacitor. And it doesn't quite reach where I need it to reach, which is pin 1. So I'm going to do a similar thing here. This one did reach, goes to pin 1, then that grid stopper goes over to pin 5. This won't reach. I can't just cut it off because, or terminate it, because it'll look terrible. So we're going to try, it comes up under this one. So I'm going to see, it may not work, but hey, we'll give this a go first. Thinking that's the wire there. So I'm hoping I can just pull this out. Wrong tool. viola. Got it. Now, obviously, I'm not going to be able to get this to come out of that hole, but let's see what we can do. I'll run this all the way under the board. I've taken out that screw. So I'm hoping, and there we go, that's come out there. It's important to have a really good connection here, or else we're going to lose half of our signal. The push side will be missing. There will be no pushing. It's a whole bunch of pulling. I'm wondering, can I get this to pop up there? Let's give that a bit more of a bend. And just a kiss of solder. Come on. Oh, there it is. Yes, yes. U-E. Now, I need to get that in there as well. And let's just push him down a bit. Might just trim that bit off. Make it look pretty. Straighten that lead, which I've bent. There we go. Let's just check continuity. Beautiful. I don't want to get too close to those filament wires. I think I might go across this way, because the filament, especially down this end, we've got our high current devices like the 6L6s, will radiate the most electromagnetic interference. I'm thinking I'm going to go up and over. And you can go in there. If you're going to have to cross over a high current carrying, AC carrying wire like this, try and always cross it over at right angles. So you're going to introduce less induced noise into your signal. And don't forget, this is our final stage of signal. Yeah, I'm going to go straight across. So now I haven't crossed over any of the filament wires. What do you think? What do you think of my acrylic nails? They look shithouse now, don't they? When they were new, they were great. So much stronger than my normal nails. And, you know, when I play my slide or I do a bit of hybrid picking, they would just break off continuously. So this is much better. They just look so bad now. Yeah, one of my amp customers, regular guy, Marty, g'day Marty, told me about it. And I thought, oh, that sounds like a good idea. The fiberboard had buckled up a fair bit, as they often do when they absorb moisture. So I undid all the screws. Yeah, this is the fairly quick way to do it, but I don't know if you remember what it was like before, but it's a hell of a lot better now. So just apply a bit of heat, take some of the moisture and conductivity hopefully out of the board, and then I just hold it down while the board cools down with my little pushing sticks. And yeah, I've still got 1, 2 and a bit bumps, but way better. I'd say it's about half the height. I'm just going to do the screen grid resistor. I just mount them a little bit out of the firing line so that they're just not going to cop quite as much heat. Brown Vichets, which I really like. For some reason, I'm finding them harder to find. They seem to be getting more and more out of stock. It's probably because you're buying them as well. I know I've got the screen current going through that resistor right above my red grid wire, control grid wire, but that screen grid should be pretty well filtered, so I don't think we're going to have a noise issue. Now you see, that's no longer going to pick up rising heat coming off there. Now I'm going to do the same thing for here. You can keep your eye on the voltmeter. I'm going to start slowly ramping up the variac. I've got power on, standby on, so there will be no surge. Okay, variac's on. That's very encouraging. 100 volts. So that the numbers I'm calling out are what's on the variac. So what's the supply AC? No arky sparkies. The pilot light is glowing. Okay, we're now at 200 volts. I'm going to stop at 230 until I get some valves in there. Well, I've stopped at 230. Now let's just test some voltages. Well, let's just check B plus on actual tube bases. 411, 411. Screens with the new screen grid resistor is 410, 411. Now here's our control grid, minus 57, minus 57. The voltage on the schematic's minus 55. We're close, but I'll show you the bias circuit. I'm not really happy with it. It's been doctored a fair bit. 1, 2, 3, 4, 5, 6, 7 tubes out, so these will all be reading high. Plates, 400. I'll just read pin 1 plates, 400, 379, 400, and this is our phase inverter, 407. They all look fine. Let's have a look at our bias circuit. You can see it's been fiddled with. We've got this resistor here cut and another one tacked in place. That's obviously to get the desired bias voltage current. Don't know how he's done it. I know how we're going to do it. And so that's been changed. He's cut that leg, so that resistor is not usable anymore. And this one should be 10K, and it's 15K. So I think what I'll do is I'm going to bring these back to original and then see where our bias voltage ends up, because we're aiming for minus 55. I'm going to put in a bias pot in here. I think let's discharge it, get this back to original, and then we'll go from there. I've got a couple of choices for bias controls. One is this one, which is a multi-turn, I think 20-turn pot, so you can get pretty precise, but it's 20K. And I've put the 10K in there, as you can see. So we're now going to be adjusting this 56K. Now, one thing which you may have not noticed, but here is our negative supply. The negative supply goes to the 10K. So obviously the smaller we make this, the more we're going to go to the negative supply, which is going to make the bias colder. Here's our 56K. It's close to ground. It goes to ground. So the smaller we make this 56K, the closer this voltage is going to go to ground, 0, which means a hotter bias, right? Negative bias, cooler. More negative, even cooler. Less negative, hotter. That will give us good control. But then, so will this. If we pitch this carefully, because this one's only 10K, this one, the other one was 20K. So it's going to give us less range, but we should give it fine control, even though it's only, whatever it is, 300 degrees rotation compared to 20 turns. As long as we pick it carefully, and the other reason why I want this is it's going to look more like a genuine Fender type of, well, it is, genuine Fender type of bias adjustment. So the question is, how do we pick this value? We want to set this to half of its 10K range so it can do its maximum adjustability. So what I'm going to do is I'm going to put a 4.7K here. So you can see what I've got here. I've got a 4.7K resistor going to that point, not soldered here, and 4.7K I've just got temporarily in there to simulate halfway in the rotation, because this is a linear pot, halfway in that rotation. And I then have my resistor decade box up here, and I've got it set to 47K. Why did I pick 47K as a start point? because if we look at 47 plus that 5, it's going to be 52k, which is sort of in that 56 range. So I'm now measuring the bias voltage. As we can see there, we've got minus 58, just a little bit too cold. So we want to bring that closer to minus 55. So we want to make it less negative. So we're going to reduce the size of this decade box. Below 47 is 39. It's 56. Below 39 is 33. So I'm thinking about putting in a 33k resistor in series with this 10k, and in its mid position we should be on the book value of minus 55. Let's do that. So I've decided to mount the pot just here, but I'm not using it as a potential divider. As you can see, that terminal is unconnected, so I'm just using it as a variable resistor. Now, the way Fender have done it in the past is they've drilled a hole into the chassis at around about that diameter and screw it in as you would a pot. However, this poor amp has suffered enough indignities over the years, or at least at the hands of the previous guy. I'm not going to do that. I'm going to hot glue it to the chassis here. You're all probably going to be screaming out, that glue's not going to hold, because as soon as it touches the cold chassis, it's going to just fail. So I've decided to do it this way. I could use double-sided tape, a really strong one. I use that double-sided tape that car makers use to adhere their emblems and things to cars. But I'm going to try this. You'll see I've cleaned just this one portion here, and it looks a little bit patchworky. And the reason I did that is because, I don't know if you can see it here, but Margaret signed her name just there. So I don't want to lose that. So I think what I'm going to do is I'm going to put that there. I'm going to do a little bit of a circle around it. That came out. I'm going to put some hot glue on the inside of that circle. But alas, you're calling out, it's going to get cold and not stick. Well, not if you haven't got 120 watts of super hot soldering iron. So I'm going to put that there until I can see that it's melting. I'm just getting pretty close to it right now. I'll give that a bit of heat as well. And now I'm going to slot that onto there and hope that that has stuck. If not, take it out, use the double-sided tape idea. But I reckon this is going to work a treat. Oh, I like that. That's nice and firm. And by using my big soldering iron that I normally use for soldering onto the chassis, however, this does not necessarily mean it's going to be the right bias voltage, so I need to be prepared to redo this. I reckon you can tuck in back there. Looks good. Looks good. You can go and tuck in down there. I'm very happy with that strength. Time to test this bias voltage again. Alright, I'm now testing the owner's original tubes. I'm hoping that they are okay. So we're going to be measuring for plate current and transconductance, 6L6. We'd like to see over 12 and under 40.
And that one's looking pretty good. This is valve number 1. So we're going to call that a plate current of 30.5 milliamps. And we're going to call this the conductance, transconductance. We want to set it over 2.2, which it is. So that is 3,270. Bugger. Plate current of 21.6, 21.7. Come on. No, that's as high as you're going to go. 21.7. Transconductance of 3,290.
Not as closely matched as I would have liked. I like them 10 to 15%. This looks more like 50%. 30.5 divided, 30.6 doesn't matter, divided by 21.7. Youch. 41% difference. That's going to make biasing a bit more of a challenge. Look, I'll install these, see if I can get it biased. Now I just want to service these sockets. Notice these things have been bent too far flat. I'll straighten them up before final assembly. Now I'm just going to spray in here this product. Removes oxidation, cleans, so I'm just going to use that to do the initial clean. I'm going to have to tighten some of these holes up as well. I'm not sure if you can tell, but the little base has stretched on most of these pins. Yeah, stretched quite a lot. And where's the little one? Is that too little? And maybe go up one. Now if these were vintage tubes, I'd also be cleaning and deoxidizing the pins on that. Now let's flush that cleaner out with a bit of IPA, isopropyl alcohol. And a bit of compressed air. Well, you can see just the overspray of that cleaner. Wow. This thing has had decades playing in smoky, greasy bars, I would say. I had to make a couple of changes. That resistor here, which I had set at 33K, because I was working on a bias voltage of, was it minus 54? Minus 55 volts. I did exactly the same thing. I set the pot halfway, then I used my decade box to step up and down until I got the actual bias right, not the bias voltage right. Then I could bias the tubes accurately. I first did what I usually do, look at the oscilloscope, adjust the bias till I get rid of the crossover distortion, and maybe just a tad hotter than that, a whisker. And then I check the voltage, the current rather, and we were looking at about 40 milliamps per tube, just over 40 milliamps per tube. So don't use this value if you're rebuilding a bias and want to put in a bias control. I'll probably steer more towards the 33K than the 10K. The 10K I had to use because our B plus voltage was, instead of being 450, it was down to 420. And I found 10K was the ideal value when the pot was set to halfway using my decade box. I did have to replace the power tubes. The original ones were so far out. So it doesn't really matter what our voltage and current is, so long as we got good plate dissipation and we're not exceeding the limits, either one extreme or the other. Got a good matched result with the new tubes. I'm using a set of tungsols. I need to do a bit of a recap. For you, it's probably only been a matter of minutes. For me, it's been weeks. So I measured all of these, both for ESR at 100 Hertz. All of them were 3 ohms or less. This one is the only one that was about 4.8 from memory, so I replaced this with an F&T. These other rubies look seriously like a rebranded F&T. What do you reckon? I tested all these. They're all fine, so I've left them. The preamp tubes, this one was okay. This one was too microphonic. I couldn't even find a place in the oscillator where this wasn't making a contribution to noise. So that was replaced. That's V2, but the first preamp tube for the vibrato channel. So that's got a brand new TAD, Tube Amp Doctor 7025, which is the low noise version. I really like that tube. I'm not a huge fan of electro-harmonics, but this bill's big enough, so that one's in there. That's part of the oscillator circuit, as is this. Back here, we've got the phase inverter, and so I'm really happy with the way that is now. And I'm just wondering if two different techs haven't been in this. Like whoever did the Ruby tubes here, the filter caps, I think did a really admirable job. Yeah, he's got the values pointing upwards on most of them, but they're all visible. The wires are relatively straight compared to some of the crap work that I've seen. This one's mine. The original preamp tubes, which I measured, were 30.5 and 21.7 plate current. I thought, that's not going to bias well. And indeed, when I put the bias checker on it, they were so far out, it was impossible to get either one in a safe operating area. So I replaced them. I put in a matched pair of tungsols, biased up beautifully. This is the power transformer that I had rewound to make it 240 volts. I also got my transformer guy to just check over the other voltages, make sure they're all happy. This is definitely a newbie. It's the Mesa Boogie output transformer. The reason I didn't sort of shriek in horror too much about this is because Mesa normally use good transformers, and indeed this one is a Schumacher transformer. I was happy to leave that in. Choke's original. Put in a new 240 volt power lead, connected the neutral straight to the transformer, connected the active to the fuse, going to the back of the fuse, coming out of the front of the fuse, going to the power switch, which then goes to the transformer. Here I put in new screen grid resistors because the other ones had obviously copped a load of heat. There was no grid stoppers originally. They came in probably the black face, and from there on in, always had them. Great idea. I installed a new bias pot, or a bias pot, I didn't have one. Required setting these two to get the proper range in there. So I used Brown Vichet resistors to look more like carbon comps. I'll point to these because these are actually ones that I had replaced. So amongst the things that the previous tech had done, these were carbon films. They just stood out like dog's balls. It's just really unattractive. So I replaced these two. I'd have to get back to the video and have a look at where they did. I think these two were carbon films. I replaced them. That one I replaced. But the biggest change was getting rid of that sea of orange. So I replaced all of those horrid orange drops with this much higher quality and way more original looking Sozo caps. Yes, they are quite expensive, especially here in Australia, but I thought they were worth the expense and the owner agreed with me. I decided to chip in these. I had two of these 0.047s, which were left over from previous repairs where the owners didn't want them. Previously, these were death caps. I tested them on my Mega and no leakage, as these things just don't leak. So that's what the owner had agreed to. There was a few other things that I did at my own time and expense, mainly because I'm just a bit of a perfectionist. What else? Oh yeah, the earth points were all soldered securely. Would have liked to have cleaned up the chassis a bit, but once I started here, I thought, I just don't want to lose that signature there. I was assuming that was the tech that originally built it, a lady called Margaret. I don't know if you can read that. Depends on how the light hits it.
That's about it. I tested these two Astrons. These can sometimes leak, but in this case, they were fine, no sign of leakage. So I was determined to keep as much original stuff as I could. I'm confident that this is going to go just fine. So I've put in a 1.5 amp fuse, which is half of the 3 amp fuse that you would use in the US, because we got double the voltage. So that's a 1.5. Printed up a little label that'll go over the fuse holder at the back. I've got it plugged into my isolation transformer. All right, all looks good. No unusual sounds. Got a speaker plugged in. Okay, I'm hearing sounds. Now, curious, does the harmonic tremolo work? Oh, I'm hearing that pulsing. I'm not sure if I mentioned, but I slowed the tremolo speed down a bit. I replaced one of the 0.01s with a 0.02. And yeah, that's greasy. And it probably still goes up to a ridiculously fast speed. Sounds great. Try the normal channel as well. Ooh. Ooh, that you can't get out of a modeling amp. That, what a valve amp does on those high frequencies, that's the money shot. All right, I'm going to put this baby back together. I think we're done here. It sounds glorious. Oh, I didn't check the foot switch on the, move out of the way, Harley. And that's with the foot switch off. Here's my temporary foot switch. Yep, beautiful. Yep. Okay, so foot switch action works. All right, let's assemble this and hear what it sounds like. This has got to be one of my favorite amps. I love that brown face era. And you wait till you hear this harmonic tremolo. OMG. It's just so different to the normal pulsing tremolo that came in 2 years after this with the blackface. This is the harmonic tremolo, and it's quite unique, quite delicious, as you'll soon hear. Probably wondering why I've got two mics and the blue tape. Well, I've been using interchangeably the Sennheiser 609 and my Beta 57, Shure Beta 57 mic. And I just thought, I don't know which one I really like better. So I'm going to sort that out right now. So I'm going to record one on each track. What you end up hearing, I don't know. I might leave both, one on one track, one on the other. That might be a cute idea. My plan was just to listen to them privately and then pick one I like best, but I might leave both. That way you can decide too. I've got the bass control on 4, treble on 7, volume on 5. That's about the sweet spot. And the sweet spot is that volume between when the amp sounds really good and when my neighbours out there are going to call the police. So 5's the sweet spot. I've got the speed currently on 1, intensity on 8. I just wanted to see how loud this is. Right, this is with volume on 5, right? You can't see it, so it's just up there above the screwdrivers. And wow, okay. We hit 116 dB. Not that far behind a super lead, so I tell you, oh, hello. Watts don't make a big difference compared to actual dB. This is about 35, 40 watts. Super lead, admittedly super lead was on 1.5. All right, now let's have a quick listen to this harmonic tremolo.
Volume back on 5. Volume on 10. Wow, it was a huge job. Take the earplug out. But I've restored it both visually and sonically. It sounds bloody awesome. Be interested to hear what your feedback is on these two mics. I've got the Shure in the left channel. Hopefully that's coming out of your left ear. And the Sennheiser on the right channel. In fact, let's just do a quick calibration. Sennheiser on the right channel, Shure on the left channel. Hopefully that worked. Let me know which mic you preferred, because whatever you reckon sounds better, because what I'm hearing in here is just phenomenal, but I need to get that phenomenalness to you. So if you've got a preference on which mic, let me know, put it down in the comments, and that's the one I'm going to pick, and that's one I'll do future videos on. Hope you enjoyed this journey with the Brown Pro, the one that was raped, pillaged and plundered by some arsehole. Now, I'd say it sounds almost as good as the original. Well, I will say it sounds as good as the original, because I'd have to really A/B it to hear the difference now, because right now it just sounds freaking awesome. Hope you liked it. If you did, can you give me a like? If you got something out of it, let me know. Comment, I'll answer every comment. I'll see you at the next video.